In this video, we're going to finish our discussion of conic sections with the hyperbola. A hyperbola has some of the same components that other conics, like parabolas and ellipses, do. So they have a center, they have two vertices, and two foci. But something that is added here is something called the transverse axis, which is very similar to the major axis of an ellipse, and it also has what we call a conjugate axis. So the difference between transverse and conjugate is that on the transverse lies the foci and the vertices and the center, and the conjugate axis runs through the center perpendicular to that other axis. So something else you see here is that these curves of the hyperbola curve away from one another, unlike an ellipse or even a parabola or a circle. So what creates that curve are these asymptotes right here that run through the center point. So like an ellipse, you can actually flip this thing on its side and have a vertical transverse axis with all the same components down here, except everything is tilted to the side. So just like other conic sections, hyperbolas can be centered at the origin, 0, 0, or at another point, h, k. That doesn't change for any conic section. Also, very similar to an ellipse, is that we could have our major axis, or in our case, our transverse axis, along the x or y axis, and that will create two different shapes, either facing this way or up that way, which we'll look at in a second. And also, much like with an ellipse, if it is along the x-axis, the foci is going to be plus or minus c, 0, and the vertices are plus or minus a, 0. So that doesn't really change. What does change is our equation and how to find these other elements here. So it's going to be x squared all over a squared and y squared over b squared, but instead of adding it like what we do with an ellipse, we subtract it. So if you think about it, these two curves go away from each other. And if it's a plus, they're going to go towards each other. So that's really the only difference, but it creates these two very different graphs. So something else to note is how to find the asymptotes for this. So you would take the b value and the a value, you divide b over a, one's plus, one's minus, they're going to give you two lines there, and make sure, if you've done this right, make sure that they go through the center point. All right, if we flip the transverse axis to the y-axis, I'm going to get my curves going this way. And like with an ellipse, the foci is then going to switch to be plus and minus c for our y values, and the vertices plus or minus a for the y values there. But what differs between an ellipse and a hyperbola centered at the origin is that the a and the b squared stay in the same spot, but the y squared and the x squared swap because of this minus sign here. With an ellipse, the plus doesn't really matter because addition is commutative, but subtraction is not, so keep that in mind. Same equation here though. Asymptotes are a little bit different. Instead of b over a, it's a over b times x with the plus and minus right there. So here's what happens when the center is not at the origin. We're still dealing with the same kind of equations, x squared a squared, y squared b squared, and then swapping them, still dealing with the minus. The only thing is that we have to adjust the foci and the vertices depending on our center, h, k. And the asymptotes remain similar, except we have to also deal with the k and the h. So I wrote these out here just in case you couldn't see them. And then here's what the graphs will look like depending on how your transverse axis goes, whether it's parallel to the x or to the y. So let's put all that information to use and find the equation for a hyperbola with center at 1, negative 2. One of the foci is 4, negative 2, and one of the vertices is 3, negative 2. So just by looking at this information, I'm not totally sure the direction of which the hyperbola is going to point, whether it's going to be horizontal or vertical. So I'm going to roughly sketch these points out. So what I noticed here is that I have my center point, to the right of that is the vertex, and to the right of that vertex is the focus. So I know that my other 2 points are going to be over here. So it's going to do one of these. Not drawn to scale. So what I've done here is I've taken the information from the chart that matches this graph and I've inserted the information that I have here. So I'm looking for another focus, another vertex, the equation, and the asymptotes. So given that I have h and k from this center, I can figure out a and c, and I can use another equation to find b here and use it here to find the asymptotes. So what I notice from the center to this focus point is that we add 3. So c must be 3. So if I do 1 minus 3, that's negative 2 comma negative 2 because that value stays the same. So I can even put that there. And what I see here is that if I go from 1 to 3, I add 2. So that must mean that a is 2. So 1 plus 2 is 3. 1 minus 2 is negative 1. So I'm going to use this equation to find b squared, to use it here. So that means b squared is 5. And I'm going to use that to write out my equation. So x minus h squared all over a squared, which is 4, minus y plus 2 squared all over b squared, which is 5, equals 1. So now I'm going to use that b value to write out my asymptotes. So that's going to be y and then minus k, so that's plus 2. It's going to give me two equations, plus and then minus. So b is square root of 5, remember, because b squared is 5. So square root of 5 over 2 times x minus 1. And if you wanted to put that in your graphing calculator, here you would just move that negative 2 over and you'd have your y value. So you could plot those two lines if you wanted as well. So instead of drawing all of that by hand, I went to Desmos to help me out. And what I've done is I've plugged in the equation and all the points that are necessary, including the asymptotes. And what I find here is that here's my center, here are my two vertices, my two foci. This red line is my hyperbola, and then this green and this blue represent my asymptotes, which check out because they go right through the center. They come very close to these lines right here, which makes it a very awesome looking hyperbola. And that's going to do it for this video. Thanks for watching.